Uh, Good morning, everyone. My talk will be in English, so that's one of two fresh outlooks you have here. All right, everyone sees it. The full name, full title will be Co-Designing with LLM, and I will speak more about cognitive basis, what I think would be the most precise wording. But first, I need to figure out this tool. All right. Just a couple of words about me and why this talk is in English, right? Well, it turns out machine learning, AI crowd, all of you already speak half English because all the terms, all the wordings and ideas pretty much encapsulated in English, or some way of, I don't know, Russian word which came from English. So I just thought maybe it would be a better idea to completely give a talk in English because, well, why not? And my personal desire is, if this talk is recorded, then I can share it with colleagues who don't speak Russian. For questions in the end, I think it's okay in Russian because my native language, and I guess 90% of people here is Russian. So what about me? I'm, first of all, disclaimer, not an AI or ML expert at any rate. I'm pretty much skeptical about all this LLM and stuff, but more reasons to give a talk about this and maybe learn more about you and all this domain. But my main reason, my main proficiency, how could I show it? So basically, I work as a field engineer, field seismologist, third of my time, and 2/3 of my time I'm working in this environment. So again, same as you probably with a computer, some coding, some writing, mix of that. And to start this talk, I will try to give you a personal story how I came up with all this all these things I discovered. Well, during my PhD, I had a big problem with cognitive load. I don't know, maybe some of you are familiar with the problem. Like when you have so many cognitive tabs open in your browser, it's starting to fail or slow down, throttle. So the same problem I had in my PhD project. So I decided maybe I just need a basis. If I will develop some sort of cognitive axis, dimensions, maybe it would help me work more productive, approach more, and stress less, most importantly. So few examples of this cognitive network or cognitive basis. Let's say not cognitive basis here, just basis. Maybe some of you familiar with the Miller article. It's one of the most cited articles in psychology, and it's called basically the magic number 7 plus minus 2. Why we struggle with cognition, with understanding more concepts and keeping them in memory. I'm not precisely citing the title, but you get an idea. And this is interesting concept indeed. 7 days in a week, 7 colors in a rainbow, whatever. Well, many symbolic links we have for this number, and it turns out indeed like 7 is a comfortable number to keep in our head most of the time. So one of the approaches I developed, again, it was mentioned on the slide, this talk is mostly philosophical, but I will try to ground, as I proceed to the core part, I will try to ground it in AI and ML topics. All right, so just bear with me for a little. Started it all with physical dimensions. Sorry, just mix the. All right, so I developed a physical basis first. You know, a size system, right? You can basically invent your own physical system, and use frequency instead of time, and I know, volume instead of mass, or whatever. So I think we could move further, right? Not too much interest in there. So this cognitive basis, it was basically developed in the last 7 years because I struggled with this cognitive world. And main reason why I'm giving talk here, and it's titled Co-Designing with LLM, is because only recently I discovered LLM for myself. I was aware of ChatGPT and all this advent of AI, and I mean, whatever. In my line of work, seismic stations wouldn't be installed by robots for quite a few years, so I'm quite safe in my work environment. However, LLM really startled me. Like, I was astonished by how well it formalizes my initial raw ideas, which not so structured. And you have here an example. Basically, I was trying to develop primitives, cognitive primitives, link them with some symbolic anchors, with some physical metaphors, and with some, actually for this topic, some AI stuff, right? So I will show you the full mind table at the end. But now let's just move in a fast pace how it's all encapsulated. Basically, I think everyone agrees that we have something called exploration, right? You can say it's in physical way when you map a new uncharted territory, or cartography and stuff. You can use it in like research when you just started with a topic and you taken an initial literature review, right? You can gather data also for research or for your ML project. So in this way, let's fix this first axis. And I think the most precise definition here, if we ground in ML, would be Bayesian optimization. So we want to explore something uncharted, uncertain, in the most efficient way, right? And I really like here physical metaphor because one of the zero dimension in this invented physical system that I mentioned earlier was entropy. And maybe some of you know what sun gives us. It's my question to the audience. would be fun otherwise. So it's basically a huge pump of low entropy, right? Not energy. It's not like transactional, like I give you money, sun gives us energy or stuff. It's more about like deeper physical concepts. So moving to the next one. Still, like exploration by itself is really good thing, but we have few danger zones. We can explore endlessly and basically do nothing else. So the second or first, if you count from zero axis, would be determination. And again, to ground it in AI concepts, that's a gradient descent. That's something, let's say this cognitive primitive is the ability of the process of structuring what we discovered with observation. And let's move on a slightly faster pace. And our primitive would be negotiation. I really like this one because it's an interesting concept both in social environment, right? When you have a peer review process, like we actually experience it right now. I'm presenting you my ideas, which is really philosophical, but I try to ground them in ML AI concepts so you would understand and maybe argue with me like, oh, this sounds legit, or this sounds like not particularly well worded. So for the AI concepts, let's stop on softmax policies. So we want to balance our inputs and obtain most optimal output, right? Moving further, we have a specification primitive. So this is something like when you already discovered and initially structured it and you have balance in inputs, you at some point, everyone needs a specification, a blueprint, because without it, it's really hard to design anything like of value, anything productional. So for these concepts, we have basically principle of encoder and decoders. So we want to maybe lose some not very relevant noise information, but we want to compress it to something really actionable and precise. Which is why the next part leads us to like generation, right? So it's again huge cognitive concept, which I believe the whole point of this basis would be try to decompose like you do in a linear algebra, right? I'm pretty sure everyone here familiar with linear algebra, so I assume with this basis we can understand each other perfectly well. And in linear algebra, you have a really powerful idea which basically influenced the whole point like, in the story, how I came up with this. When you have a orthogonal axis, you can decompose pretty much anything and get a very, very usable representation, right? So this generation concept by itself, I think it's mostly well defined by any generation, any diffusion models, right? But to ground it more in something in between MLAI and science, it's Monte Carlo Markov chains, Monte Carlo. It's a well used method in science, and I think some of you are already familiar with it in our context. Finally, not finally, but almost penultimately, this is the concept I'm especially proud of, but I don't really like the wording here because it invokes some religious connotations, and I wouldn't like to really go in this direction. One of the reasons I tried to develop it with ML, with LLM, was what I could basically say, yeah, let's focus, let's leave out any esoterics, let's leave out any like extensive symbolism, and focus on some physical grounds, mathematics, and basically common sense. And this was really interesting because sometimes it still hallucinated and provided some references like alchemist's role, and I was able to constantly remind it and obtain somewhat reasonable result, but still, it's an interesting case study how you interact in a philosophical dimension with LLM and try to stray away from pseudoscience. So basically here, transformer algorithms, attention heads, all that good stuff you get in insight, like these aha moments. And finally, the last one, like basically fittingly, integration. After all, everyone wants to have something finished, something completed and integrated. And this is a whole process, in my opinion, in itself, like a cognitive. You may already see it, but I didn't really mention it here. This is a somewhat like acting somewhat like an outline for my presentation for this core part, but also a symbolic links and let's say time management, because 7 days of weeks you can basically, I'm trying to implement in my daily life this workflow, but in a Sunday like today I'm exploring something new, and on the Saturday I'm trying to conclude what this week was about. So finally, I hope not everyone is asleep. Someone's still listening. This is a table more designed for all this philosophical stuff, so I wouldn't bother you reading it. This is examples I have from my personal work, like professional, work, of applying this more basic, more foundational basis, let's say, of linear algebra when you're trying to decompose. You see here like matrices, and if you count eigenvalues, you can use k-means to cluster some data. So basically, very powerful, even not technique, strategy, I say. And finally, the slide you was waiting for, and I hope I didn't really bother you with all this philosophy, but sometimes fresh look is really valuable. Here I tried to encompass this 7-axis basis into something actionable with LLM, and also outline how I use this co-designing process, which was actually like the title of this talk, right? Co-designing with LLM, like just 7 tips how to do it, which are linked to this basis as a result of doing it. So I don't know, I found it amusing, very how you can interlink this all. And here, let me explain. You have a metaphor, which is not very physical based. My initial physics metaphors, it's very subjective. I mean, not everyone really likes physics. But here it's more about something I feel you would understand really well. Last column is some actionable tips how to use this. How to use this, basically examples how you can prompt something to LLM and get a result according to this philosophical basis, let's say, right? But it's not limited to that. You can use it, you can forget the total 7 magical number and whatever, and just try this, apply to your task. And well, with that, some references. Really recommend this video about 7 dimensions in physics, very funny one, and a few articles that I myself intend to read deeper. And I'm ready. Hope we have enough time for some questions. Можно на русском, если удобнее, то есть.
Спасибо за доклад. Это не совсем вопрос, сколько скорее.
Нестандартный получился, да?
Да. Это у меня скорее не вопрос, а такая, может быть, рекомендация. Возможно, вам будет интересно что-то более лингвистическое, в смысле, помню, что LLM — это в первую очередь большие лингвистические модели, и касательно метафор, просто есть большой пласт семиотики и лингвистических работ про метафоры, metaphors we live by, как они ограничивают и преобразуют значения. Мне кажется, это может быть добавить еще одно измерение просто к вашей системе.
Спасибо за рекомендацию. Да. Тут краткий совсем комментарий. Я изначально подавал на неформатные рандомы DSML. Как-то так случилось, что это в Advanced LLM попало. И я постарался как мог заземлить это на эту тему, но как бы не судите строго. С другой стороны, свежий взгляд, это философская проблема очень, я понимаю. Тут, но в этом-то и интерес. Это вот такой кейс-стадии, как можно применить, где это вот не принесет конкретную прибыль прямо сегодня. Да, еще вопросы, может быть?
Thanks for really interesting discussion report. I have.
You're welcome.
Question, maybe I missed this, but you've shown an example of measurements. You did some matrices, some graphs.
You mean this one?
Yes, this one.
Yep.
But LLM takes an input as a text. So
yeah,
what's an example of the workflow? How you use LLM to analyze data like this?
Okay, I think I got what you mean. Basically, I just finished developing it, and it's still in a beta phase, let's say. I slightly cheated with the talk title, like personalized cognitive engine architecture basis. Basically, it's only basis and cognitive at this point. No architecture, no engine. Definitely, I'm not competent enough to do that. So I tried to implement some of my mental struggle with trying to develop these primitives. And I used the LLM to verify, to peer review my ideas, suggest something else, rephrase, formulate it better. And basically, if you like an example of how I interacted with LLM at this, it's in this column, right? Or this column you can basically see the patterns I use. But yeah, like it's still more like philosophical topic. But sometimes it's interesting to tackle these problems.
Of course, thanks a lot.
Are we good on time? I think most of the people wants to go to lunch at this point.
Ну, у нас есть еще пара минут.